many roots?
Do
Irrational
all
roots also-
irrational roots occur in pairs, like
Yes.
unreal roots, you're asking?
Yeah.
I mean, complex roots, not necessarily, I think,
Yes, correct.
because
So
we
actually,
did minus 0.6, it didn't have a pair.
Yes, correct. So there's only few situations where the irrational roots are in pair. So they would look something like, let's say, a. I is something which is greater than equal to 1 and less than 1. Would this ever hold? For example, you can yourself test. What is the solution of this inequality? This. And what is the solution of this inequality? Is this? What is the intersection of these two? Is
Nothing.
it 5? Yeah.
Yeah.
So that means your entire answer is this much only, right? Actually, if you observe, this is nothing but sum taken 2 at a time only. So that means if any such thing arises in front of your eyes, you can, and rather than doing all of this, you can just use a formula, which is that, do you remember this formula? A plus B square is A square plus B square plus C square plus 2 times AB plus BC plus CA. Is this sum taken 2 at a time? Because you have only 3 things in consideration.
Yeah.
Okay. What is this? Is this sum squared? And is this square of sum? Sorry, sum of squares. Sorry, sum of squares. So if I bring this to this side, it would be sum of squares and divide by 2. So that is your sum taken 2 at a time. And this is valid for any n, actually, any n. If you can take n as 5 also, then also it would be valid. So this is the formula that you should keep in mind. Okay, so these were a few set of topics. Now moving to another part. Okay.
Okay, give me 1 second. The current's back on. I'll switch off my mobile hotspot and I'll jump to Wi-Fi.
Okay.
You'll give me just 1 second.
Okay.
Yeah, can you hear me?
Yes.
Yeah, now it's fine.
Okay. So next topic is Newton's formula, very famous. So what happens is, let's say you have a quadratic. This is actually, we studied for quadratic, but this is valid for any equation and any nth degree equation, right? So what happens is, we frame something called as, let's say, an, which is k times alpha. Let's say its roots are alpha and beta. Alpha power n plus lambda times beta power n. And we can write this as, since 2 is here, so a times, okay, let me call this an, capital An. A, what do I write here? Do you remember? N plus 2 it would be.
Oh, okay.
N plus 1 plus C A N equals to 0. This is how you, I'm sure you would have read this.
Yeah.
Okay.
Wait.
Yeah, and this would be valid for all n belonging to natural numbers. Okay, don't take whole numbers.
Yeah.
Okay. So
1 second, I'll just note it down again.
Yeah.
Yeah, done.
Okay. Now moving forward, another topic, something called as nature of roots. So let's say we assume a base quadratic equation. First case, A, B, C belonging to real numbers. Now you know D is 0. What does that mean? D greater than 0. What does that mean? And D less than 0. This you know, right? Just one thing again I can say. This means that it will have no real roots, right? And since it's a quadratic equation and we know non-real roots occur in pair, so if it has no real roots, that means it will have 2 non-real roots and they would be conjugate of each other, right? Okay. Another case is A, B, C belongs to rational numbers. So let's say your D is a perfect square. So it will have 2 rational roots. And let's say your D is greater than 0, but not a perfect square. So it will have 2 irrational roots. Right?
Yeah.
Okay. Okay. Do you think all irrational roots occur in pair, like how complex roots occur? Imaginary roots.
Uh, do all
Irrational roots also
irrational
occur?
roots occur in pairs, like
Yes.
unreal roots? You're asking.
Yeah.
I mean, complex roots. Not necessarily, I think,
Yes. Correct.
because
So
we
actually,
did minus 0.6. It didn't have a pair.
yes. Correct. So there's only few situations where the irrational roots are in pair. So they would look something like, let's say, a plus b root c and a minus b root c. Not always. So you can, remove this confusion from your head. Okay. Let's say a is 1 and b comma c are belonging to integers. And your d is a perfect square as well. Then what will happen is you will have integral roots. This is a famous condition. A lot of questions are asked on this sometimes. Okay. This was this nature of roots.
Oh, sorry, I was on mute. I was saying yes.
Okay. So now sometimes what will happen is you'll be given two quadratics and you'll have to compare. Let's say a1x square plus b1x plus c1 equals to 0, a2x square plus b2x plus c2 equals to 0. Okay. Let's say this has discriminant d1 and this has discriminant d2. If d1 plus d2 is positive, if d1 plus d2 is 0, if d1 plus d2 is negative, only these cases are possible, right? So if d1 plus d2 is positive, that means definitely one of them is having their individual discriminant as a positive one. That means definitely you will have at least two real roots. See, there are two quadratics, right? How many total number of roots should be there for both of them combined? That should be 4, right? So out of those 4 roots, at least two will be real if d1 plus d2 is positive. Right? If d1 plus d2 is 0, again two cases. One is that both are 0. Another is that d1 is the negative of d2. If this is the case, then you'll have 4 real roots. Right? If this is the case, then you will have exactly 2 real and distinct roots. Okay. And if it is negative, so there will be definitely one of them has to be negative. That means at least 2 non-real roots. Okay. How do you divide polynomials? Do you use any shortcuts?
Could you go
Like
1 second? I was saying, could you just scroll up 1 second? I'll just take a screenshot.
Okay.
Yeah, sorry. Yeah.
Okay. So how do you? So actually, for division of polynomials that you might have to do at some instances, there's some shortcuts as well, right? One is the long division method only, right? Synthetic division, whatever names are there, synthetic division. I prefer this only. I just divide it, right? Some people use shortcuts, right? They'll just write coefficients. Something tricks are there. So how do you do that?
I just do long division.
Yeah, that's better. So use that only. Okay.
Synthetic division is the one where I think I know what you mean by synthetic division. And like then there's the remainder theorem also.
Yes.
Yeah, I
Yes.
just do long division.
Okay, correct. Good. Remainder theorem you can not use when you have to find the expression, right?
Yeah, that's only when remainder is needed.
Yes. Okay.
And isn't even synthetic division if only it's x minus a. So
Yes. Yes. Okay. Next topic is common roots. So let's say you have another set of two quadratics. Okay. Let's say they are saying it has two common roots. See, this has two roots. This has two roots. Could be real, non-real, I don't know, but definitely two roots would be there because the degree is 2, right? Okay. Now, what if the two roots that this has are also the roots of this only. So all are same. So that means 2 common roots. So for this, the ratios should be in proportion. Let's say they say have a common root. This actually means have a common root. This actually means that one root is definitely common. What about the other root? We don't know. Right? Could be also, we don't know. So if this is the case, I would say you just consider that common root as alpha, put it in both the equations, a1 alpha square, whatever, a2 alpha square, whatever. Solve these equations, right? By matching these coefficients, right? Eliminating this alpha square, right? You will find your alpha. Some remember the direct formula for alpha. It is very, complex. So don't overload.
Yeah, no, I'll just substitute and do it.
Okay. Perfect. Now let's move on to the next step.
Many students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.